But with anything that you see, including this marker I have here, right? Now, most strictly, we want to reason as strictly as we can. Right? We want to know whether what would describe most accurately your perception of this. Do you see the whole of it? Because when you see it, would you not agree there are parts of it that you don't see? Therefore, you don't see the whole of anything that's three-dimensional, because there's always a part you don't see. So therefore, in perception, all you see is parts. Would you agree you don't see all of the parts in a unity? You assume all the parts are in a unity, and you hope, seriously enough, that they will remain together. But you don't see that. You infer it. You make a judgment. You make a judgment that when I turn this around, its parts that were not visible to you now will become visible. So you infer a whole. When we call it one marker, we mean something curious, because if there's a difference between a one and a unity and a parts and a whole, in what way can we say one sees a one? For from our reasoning, what you really see are parts. You infer it has a wholeness to it. You infer the parts coming together as a whole has a unity, and that the unity implies, again, a one. Now, furthermore, would you not agree anything that we're talking about is subject to change? And if we wait long enough, whatever we're talking about will fall apart and become parts of something else. So therefore, it looks like we can say that everywhere we do this curious thing calling things one, it's not in the perceptual realm that we see the one. Now, somehow we grasp it as one. Look here. We grasp it as one. Would you not agree that all of the arts of camouflage is to take something and blur the boundaries in such a way that it seems to flow into the surrounding, merge with the surrounding. Therefore, you don't see it, you don't grasp it as one, even though it's visible, having all parts and a whole and a unity. So therefore, you need a boundary. You need a boundary. You need some kind of boundary. And you want to say something about the boundary, that it's not itself a part. It's not just a unity, but it has a continuation. Something happens to it with the unity. Now maybe we can take this idea of one and apply it for a few moments to the idea of its symbolic representation. That's what we're going to do next. Look here. I have a name that I'm talking about. I'm talking about one. I have a symbol, Arabic. I could also use Roman, and other ways of symbolizing one. Right? Now, let us now apply this idea for a moment to take another number, 2. It has a symbol, and would you agree it has parts? Right? And it has a unity. So the parts itself each must be a one. Each must be a one. And they must come together, and then in that unity we call them 2. Because would you agree if I put one over here and 1 over here, if I mean to consider that together, I have to in some way embrace them together to call it a 2. So for each number, regardless of what number we're talking about, all it is are many ones. That's all they are. The whole arithmetic is nothing other than many ones. Now, the many ones, wherever we stop counting, as it were, then we just have this, don't we? An unending number of ones. And if I say 3, I mean this collection. If I mean 4, I take that collection, and so on. So therefore, numbers are nothing other than a collection of ones brought together into a unity. But this isn't enough. There's an assumption we're making about representing this idea of 1 symbolically, and I'd like to take a minute out to propose something. And that will be this. To represent symbolically the number 1 is extremely difficult. And let me see if I can represent the difficulty. Suppose I put down this mark and say that's what I mean by 1. Now, we're going to take this as its field. Isn't that likely that to really ensure that I mean by 1, that doesn't happen? Because now, or this doesn't happen. So therefore, would you agree, I mean by 1? No. Gosh, this has to go on unendingly. But by the same logic, would you not agree, we wouldn't want someone to do this or this, and therefore to represent this adequately, we need this again. Now, I wonder whether that's enough, because actually someone might do this, might they not? And therefore, to represent the idea of 1 symbolically, to understand what we mean, would you not agree it entails that we have this? And by the same logic, now look here, if I have this, what happens when I do this? Well, then I have half. Well, then, therefore, would you not agree, this has to go on infinitely? All of these have to go on infinitely? And equally well, what would happen if, by the same process, I were to do this? And therefore, would you not agree, I have to continue my work? And therefore, if I really want to write the number 1, would you not agree I need an infinite space to adequately represent what I mean by 1? Now, then there isn't room to add 1 and 1 is 2. You need another plane. You need another plane, and then you're adding in a different way. You need to create different spaces to do these mathematical processes.